So when we were looking at pre-calculus, what we did was we factored out leading coefficients, right? We did that briefly when we talked about transformations, and now we're talking about transformations again, and so we need to factor them out. So here I have 3x plus 2, and I want to factor out my leading 3. So you could think of factoring as reversing the distributive property, okay? And so when I factor out my 3, what am I left with? Well, I have the x, but what do I have to multiply 3 by to get 2? Well, that's 2/3, right? So I take the 2, I divide by 3, and that's what goes here. Okay? Similarly, I can factor out a pi from this next one. I have pi x minus pi over 3. So I pull out the pi, and what am I left with? Well, I have x minus, well, what do I have to multiply pi by to get pi over 3? That's 1/3. Okay? And it looks kind of funky here, but it's not any more difficult. If I have x over 2 minus pi over 6, I want to factor out the leading 1/2. So 1/2 times x is x over 2. What do I have to factor out from the pi over 6? Well, let's think of it this way. What do I have to multiply 1/2 by to get pi over 6? Well, I definitely need a pi on top. And 2 times 3 is 6. So when I factor out the 1/2 from x over 2 minus pi over 6, that's just 1/2 times the quantity of x minus pi over 3. Now, why do we have to do this? Well, we need to be, what we're talking about in this section is not only do we do our basic transformations of sine and cosine in terms of vertically flipping, vertically stretching, changing the period as a horizontal stretch or compression, and then shifting it up or down with the midline, we also need to start looking at horizontal shifting, okay? And so you could think of this as b, because actually our function is going to be y is equal to, let's look at this one here, y is equal to cosine pi x minus pi over 3. When we looked at this back in pre-calculus, what we were concerned with is that this number here, this minus pi over 3, combines both a horizontal stretch or compression and a horizontal shift. Okay, so this function here is not really shift pi over 3 to the right. It's actually 1/3 to the right, and we are horizontally compressing our function by a factor of pi. So we need to separate those two factors out of here. So when we look at the first thing that we're going to graph, we have to factor first. And what I'm talking about factoring is this right here. Okay? And so we just did that. And so let me say that this is y is equal to cosine of pi times x minus 1/3. Okay? That's what we want to factor out. Why do we want that? Because this is b, and this right here is our horizontal shift. Okay? So as we go through this, let's go through our typical questions. The only thing that's new is this. Okay? Is this vertically flipped? No. What's my amplitude? It's 1. What is the period? Well, remember that period is equal to 2 pi over b, and in this case my b is pi, so the pi's cancel, and my period is 2. Now what is my horizontal shift? It's this. It's 1/3 to the right, and my midline is y equals 0. Okay, now that we've pulled all that out, now the fun begins, because we need to set up our graph, and the most challenging part, I think, is our quadrantal angles, because not only have we changed the period to 2, that's actually not that bad, we've shifted our graph so that the period that we're going to graph starts 1/3 to the right. Okay, so let's take a look at setting this up first. Okay, our midline is 0, which is nice, and so we're going to go up to 1 and down to -1. Now here's where it gets interesting, and we're going to do a bunch of stuff with some fractions. So that's why I've been telling you guys to practice. The first thing I would start is with this 1/3 to the right. So this is 1/3. Okay, and where is this going to end? Well, we've shifted 1/3 to the right, but we have to add 2 to that, right? So we start with our 1/3, and we add 2. Well, 2, right, is 6/3, right? And so what we're going to do is we are going to end at 7/3. Okay, and we still need to come up with our quadrantal angles. We found the first and we found the last, but we need to find the others. So it's in our best interest right now to figure out what a quarter of a period is. Okay, so 2 divided by 4 is 1/2. So a quarter of a period is 1/2. Now, basically what you need to do is start with 1/3 and then add 1/2 and then figure out what that is, and then add another half to get to that, and then add another half to that, and if you add another half to that, you're going to end up at 7/3. But as you can see, this could be some sort of logistical nightmare with all of the fractions, right? So when you're talking about 1/3 and 1/2, your lowest common denominator is 6, right? So I'm going to write 1/3 as 6, and so that's 2/6. And to that, I'm going to add 1/2, which is 3/6. Okay, I'm always going to add 1/2, which is 3/6. And so what does that get me? That gets me 5/6. Right? And so that's what this is right here. So then you take your 5/6, and to that you add 3/6. And what do you get? You get 8/6. And 8/6 simplifies to 4/3. So this is 4/3. Now, before we add our next 1/2, we don't want to take the 4/3. Okay, what we want to take is we want to take the 8/6, so that we can add 1/2, which is in 6 as well. So we have 8/6 plus 3/6 is 11/6. So this is 11/6. And I just want to make sure that this is going to end up okay, and that my 7/3 is right. So I have 11/6, and to that I add 3/6. And that gets me to, oops, wrong color. That gets me to 14/6. And that simplifies to 7/3, and so I know I'm done. Okay, so that was the hardest part. What we had to do is we had to first account for our horizontal shift. That's our starting point. And to that we add the period. Okay, and then from there we divide our period into quarters. And so we take our starting point and add a quarter of a period. Take that place right there and add another quarter of a period to get this. Then we add another quarter of a period to get this, and then we check our answer to make sure that we get here to our final destination by adding another quarter period. And then the rest is easy, right? Because all we do now is we put out our dots to make a cosine wave. And cosine starts high and ends high. So we start at the top, go through the middle, down to the minimum, back up to the middle, and then back up to the top. And that helps us to get our 5 key points. I didn't actually draw this. Let me draw it in. Here is my cosine wave. Alright, so my 5 key points are 1/3, comma 1, 5/6, comma 0, 4/3, comma -1, 11/6, comma 0, and last but not least we have 7/3, comma 1. Okay, so always start with your horizontal. So first you factor, right? You factor the thing that you are sine or cosine. That helps you figure out what your B is to determine your period, and then you separate out your horizontal shift, right? When you graph, you start with your horizontal shift, add a period to know where you end, then take a quarter of a period and add it to each one of your quadrantal angles as you find them. And then you just make the dots and connect them to get your graph. From there you can read off your 5 key points.